2NURFM, a broadcast service of the University of Newcastle.
He is back with us, but he is back from a work junket to Saudi Arabia. I'll try that again, from the School of Mathematical and... I think I've been
Mathematical and Physical Sciences.
Is that where you work, John?
Newcastle.
Thank you, John. Look, that's my fault for starting to have a go at you early on, isn't it? But this junket to Saudi Arabia, you just missed out on seeing Trump come in. You just didn't quite get there.
Let's get the junket right. It was a week work.
Work
I
with
follow it, yes, and I missed him, yes, all right.
No, maybe next time. You had your autograph book ready to go. You don't want any part of this, do you? He's shaking his head at me and saying no, just like most women, but that's all right. This morning, a very interesting topic. We're talking about getting fuel from CO2. How is this going to work?
Well, I guess the first thing is, why do we need fuel from anything else? There's tons of it in the ground, but unfortunately that pumps CO2 into the atmosphere, which is a problem. But and certainly there are alternatives. We have electric cars and so forth, but it's not likely we're going to have electric planes. Electric 747s? No, it's pretty unlikely. The same thing with trucks. I mean, getting electric vehicles there is going to be a challenge. So maybe it'll happen sometime, but in the meantime, we need to come up with fuel that doesn't add to the CO2 in the atmosphere. So the best thing is to actually take the CO2 out of the atmosphere.
Okay, so take us through it, John. How are we going to do that, and then how's the fuel going to come from the CO2?
Well, there are currently methods of using solar energy to extract hydrogen from water, and there are a couple of different pathways there. And there are ways of breaking CO2 into CO and C, so carbon monoxide and carbon. Now, with those, you can make very simple fuels. You can make methanol, for instance. They can also make formaldehyde and other things. And although formaldehyde it doesn't burn, it can be used in a fuel cell. So those are fairly simple fuels. What you really want to do is to start to string some of these together, a bit like a string of pearls, and have more than one carbon in there. Methanol is just one carbon. So you want to try and string it so that you actually have more, because that makes the fuel less volatile, easier to handle, and so forth. But the straight solar energy reactions don't allow you to do that. You need something else in there to help you, and that's where bacteria come in. They've been doing this for a long time. So bacteria can take the two components we've just talked about, extract them from, separate them with solar energy, and the bacteria then can plug them all together like a string of beads, and produce a higher carbon number fuels. So,
with this process, what can we see the applications of it? I mean, we get the fuel from it. Are we going to be flying planes? Are we going to be driving trucks?
Well, certainly they're the two obvious areas where you would be using this, because you're not putting a net amount of CO2 in the atmosphere. You're pulling CO2 out of the atmosphere, putting in this fuel, and then burning it. So basically, you're just recycling the CO2, so the net result of this will happen, of course, once they build up efficiency. At present, some of the processes are fairly efficient. They've got the extraction of the hydrogen. They can get around 10%. They reckon they can work that up to 20% efficiency from solar energy, which is really good. And of course, when we're talking about 10, 20%, we should benchmark that against photosynthesis, because, of course, there are biofuels. People grow sugarcane and convert that to fuel, but the efficiencies there are really low. And so,
what are we talking, John?
Oh, typically 1 or 2%.
Oh, so it's virtually nothing.
Well, it's
1%.
It's enough to do it, but it'd be nice to get it up to around 10-20% mark. So the hydrogen they've got there, they're getting close to that with the CO2 breakup. The question now is to actually put all three bits together, the CO2, the hydrogen, and the bacteria, to then produce something at a large scale. Now, this is not the sort of thing that's happening, that's going to be out in the petrol stations next week. This is part of a process which is reported in a recent Physics Today, that popular coffee table magazine. It is at home. Anyway, so this is a very long-term integrated project where, over the next 5 or 10 years, we're likely to start to see the production of these fuels.
We say 5 or 10 years, but that's not really a long time.
No,
really.
No.
No, I mean, if we can get that between 5, 8 and 9 years and get that 10% return, that sounds good to me.
5 or 10 years, we could be seeing a lot more electric vehicles around too.
Well, we could. That's a whole other discussion, isn't it? John, thank you so much for coming. Jet lagged and all. But you sounded better than me at the start, so I'll take it. From the School of Mathematics and Physical Sciences, John O'Connor joining us. Fuel from CO2. I like the sound of that. 2NURFM 103.7.